Alrighty, so the first thing we're going to do is we're going to open up static structural. Our engineering data is fine for this one, so we're going to go ahead and open up our geometry in Design Modeler. Wait for this. Go to the XY plane, change the view so we look at it, and then we're going to start sketching. But first I want to make sure that our units, I'm going to make a millimeter. I know the problem is in terms of meters, but this is actually just a little bit easier for drawing everything together. Draw these lines. We're going to dimension all of the vertexes together. And now we can start changing these to 250 millimeters for the 0.25 meters that they tell us in the problem. Just going to zoom to fit and then have it face the actual sketch. So now I'm going to generate this, and then we're going to go back to modeling. We're going to see that we have our sketch here. So we're going to go to concepts, lines from sketches, and then we're going to click apply because it selected the entire geometry. So now we have this line here, but now we're going to go up to the top. We're going to create a new cross section. You're going to see it's not going to let me do that until I click out of here and click generate. Now we can go back up to concept, cross section, and create our rectangular cross section. So it does this for us automatically, and then we just need to type in the dimensions. So ours are 2.5 millimeters by 2.5 millimeters. So now we're going to go ahead and click generate again. Right click, zoom to fit, and now we're going to go back. So we see here that we have a line body, and our cross section, we're going to create that as rect1 because that's what we just made up there, and then we're going to click generate. Now we should be all done here, so we can close out of Design Modeler. We're going to go into Model in ANSYS Mechanical, and we're going to do some changes there to our boundary conditions and get the problem set up. When the model's fully loaded in and meshed, it's going to look like the three lines that we drew, but there's going to be a bunch of points all along them. Line body meshes look a little bit different than stuff we've seen so far in class. So now here, I'm going to right click and click generate mesh. Take a second, and those are all those mesh sections that I was talking about earlier. We're going to come up here and change our selection mode to vertex. It's just going to make it a little bit easier for this part. And in static structural, we're going to right click, insert, fix support. We're going to select this first vertex here. If it will let me. There we go. So now I'm going to rename this. Let's see what point that is. That's node 3. Okay, we're going to right click, insert a fixed support. Click that vertex. And this is going to be node 1. And we're going to do that one more time for node number 4 over here. And the reason we're doing these separate is because now when we go to calculate the reaction forces, we can actually calculate them for each individual node and not just the sum of the 3 nodes. So now we're going to go into solution. I'm going to right click, insert, and we're looking for total displacement. So we're going to look up total deformation. We're going to do that for all bodies. We're going to right click on solution again. We're going to add a probe and force reaction. We're going to do that at points 3, 1, and 4. So we're going to have 3 of these. So this one is going to be node 3. I'm going to rename this force reaction 3. Come up here, right click, insert, probe, force reaction. This one's going to be node 1. Oops. And then we're going to do that one more time. Probe, force reaction for node 4. And then rename this just so it's a little bit easier to tell. Alright, so we've done our nodal displacements, our reaction forces, and now we're going to do our stresses in bar elements. So for that, we're going to right click on solution, click insert, and go to beam tool. Beam results kind of breaks this down into a little bit deeper section, but we don't need that. The beam tool will give us everything for every body that we have. So one thing that we didn't do is apply our force at node 2, which is this one at the very bottom here. So now we're going to go back, right click on static structural, click insert, and add our force. I'm going to select this little node here at the bottom. We're going to click apply, and then we're going to change to defined by components. And since we only want movement in the y direction here, we're going to keep all of these at 0 except for y, and we're going to make this minus 2000. That's giving us our minus 2 kilonewtons at 0.2. And let's just check through one second and make sure that we have everything set up right. Alright, I think that's pretty good. So now we're going to go ahead and go up here and run our solution. Okay. So let's see. So we got total deformation. So if we play this through, you can see how it kind of moves. Only 0.23 millimeters of displacement from the bottom node, so that's not terrible. And then if we click through the reaction forces, we'll see the force at node 1 here is 585 newtons off in that direction, and what we expect at node 4 is the same magnitude, just the opposite direction. Node 1 should pick up the rest of that slack, which is about 1100. And then when we go to click on our beam tool, we can see our direct stresses, so which ones experience the most stresses, and then the combined stress for each, so it does change a little bit down at the bottom there. But yeah, that's the project.